Absolute value equations. To solve absolute value equations, you need to remember the meaning of absolute value. It is the distance of a number from zero on the number line. It is always positive. The absolute value of -5 is positive 5. The absolute value of positive 5 is also positive 5. The absolute value of 12 minus 5 is 7. The absolute value of 5 minus 12 is also positive 7. When solving absolute value equations, we need to remember that the expression inside the absolute value could be either positive or negative. Let's look at some examples to see how we use this when solving equations. When solving absolute value equations, we need to write two equations, one equal to a positive number and one equal to a negative number. In this case, the two equations are our solutions, 5 and -5. Both of these numbers will make the absolute value equation true. In example 2, we write two equations, 2x equals 10 and 2x equals -10. We need to solve both of these equations. Divide both sides by 2 for x equals 5. Do it again in the other equation for x equals -5. Our two solutions are 5 and -5. These two solutions will both make the original equation true. Before beginning example 3, we need to remember the definition of absolute value. An absolute value is always positive. In example 3, we are told that an absolute value equals a -5. This is impossible. Therefore, we know that we have no solutions. Whenever we are told that an absolute value equals a negative, we know we have an impossible situation and therefore we have no solutions. Once again, in example 4, write two equations. X divided by 4 equals 7 and x divided by 4 equals -7. Solve both equations. In the first case, we multiply by 4 on both sides for x equals 28. In the second case, we do the same thing. Multiplying by 4 on both sides gives us x equals -28. Our two solutions are 28 and -28. Up until now, all of our solutions have been opposites of each other. Starting with example 5, this is no longer true. Write the two equations for example 5. We get 2x minus 4 equals 16 and 2x minus 4 equals -16. Solve both equations. Add 4 to both sides for 2x equals 20. Divide both sides by 2 for x equals 10. Now let's do it for the other equation. Add 4 to both sides for 2x equals -12. Now divide both sides by 2. This answer is x equals -6. It's very important to solve both equations since they will not always come out to opposites of each other. Example 6 is the first example where we have seen a number outside the absolute value. Whenever there is a number or an operation outside the absolute value, we need to isolate the absolute value expression before we write our two equations. You cannot do any operations or any changes to the inside of the absolute value until you have isolated it. Divide both sides in this case by -3. Remember, we do nothing with the inside until after we have the absolute value by itself. We now have the absolute value of x minus 4 by itself on one side of the equation and +5 on the other side. Now write two equations. X minus 4 equals 5 and x minus 4 equals -5. Solve both equations. Our first solution is x equals 9. Our second solution is x equals -1. So our two solutions are 9 and -1. Now pause the video and try the next example yourself. Now that you have tried it, check your work. First, remember that you can do nothing with what's inside the absolute value till it's been isolated. So divide both sides by 2. This gives us the absolute value of x minus 4 is equal to 5. Now we can write two equations. X minus 4 equals 5 and x minus 4 equals -5. Solve both equations. for x equals 9 and x equals -1. Our two solutions are 9 and -1. As we start example 8, remember that we cannot do anything with whatever's inside the absolute value until it's been isolated. So we could just treat it as an invisible box. Divided by 4 equals 7. Now multiply both sides by 4. This gives us the absolute value of x minus 3 equals 28. Now we can look inside our box since it's isolated. Write two equations, x minus 3 equals 28 and x minus 3 equals -28. Solve both equations. Add 3 to both sides. For x equals 31, add 3 to both sides on the other equation. For x equals -25. Our two solutions then are 31 and -25. Now pause the video again and try this example yourself. Now that you have tried it, check your work. Remember that our first job is to isolate the absolute value, not to look inside it. So I will treat it as an empty box. 5 times the absolute value plus 3 equals 23. Subtract 3 from both sides of the equation. This gives us 5 times the absolute value equals 20. Now divide both sides by 5. This gives us the absolute value equals 4. The absolute value of 2x minus 3 equals 4. Now we can write two equations. 2x minus 3 equals 4 and 2x minus 3 equals -4. Solve both equations. Add 3 to both sides. For 2x equals 7. Divide both sides by 2. For x equals 7 halves. Do the same for the other equation. Add 3 to both sides. For 2x equals -1, divide both sides by 2, for x equals -1 half. The two solutions for this problem are 7 halves and -1 half. In our last example, example 10, the absolute value expression appears twice. As long as it's the same absolute value expression, which it is in this case, you can solve the equation. If these expressions were different, you would not be able to solve it. So let's think of it as an equation with the variable on both sides. The first step then is to move the variable. Subtract 6 times the absolute value expression from both sides of the equation. This gives us 2 times the absolute value minus 2 equals 12. Now add 2 to both sides of the equation. This gives us 2 times our absolute value expression equals 14. Divide both sides by 2. We have now isolated the absolute value expression, for the absolute value of x plus 5 equals 7. At this point we can write two equations, x plus 5 equals 7 and x plus 5 equals -7. Solve these two equations for x equals 2 and x equals -12. Our two solutions then are x equals 2 and x equals -12. That's the last of our examples. In every example, remember the steps were: isolate the absolute value expression by treating it as a variable first, get it alone on one side of the equation, then write two equations, solve both equations, and you have your two solutions. Please refer back to these notes often as you complete your homework. Thank you.